Wonderful. Welcome everyone to a Friday afternoon, at least on the East Coast, seminar provided by the Skills and Workforce Development team for the Bridge2AI Consortium on Precision Medicine, also known as the Voice Data Generation Project. And we have two wonderful people who have been intimately involved with this consortium presenting for us today. We have Alexandros Sigaras, who's an assistant professor of research in physiology and biophysics at Weill Cornell Medicine in New York, and is the lead of the tools development and optimization module of this consortium. And we have Alistair Johnson, who currently is a researcher for Microsoft and an independent consultant for Glowyr, where he provides support for research and development projects, specializing in biomedical data and machine learning. Uh, both of these folks have been extensively involved in various components of this consortium, and you'll get to hear about the effort that they have put in towards creating a data acquisition platform and a data dissemination component of the data that's been acquired through the platform. Over the last 2 years, Alex and his team has put together a fantastic app for clinicians to help collect data that you will hear about. And Alistair and his team has put together various standards for taking that data that's aggregated and disseminating it together with tools that can allow you to process this data. So without further ado, and knowing that the time is short, I'm going to pass it on to Alex, I think, who goes first.
That is correct, Satra, and thanks for the great and warm introduction. It's a great pleasure to be with all of you today and talk about our work in Bridge2AI. And I'm going to try to share my screen and walk you through what we're going to be seeing today. So this should propagate in your screen. If I could have a verbal confirmation whether you could see it.
Yes, we can see it.
Perfect. So today, as Satra mentioned, we're going to be taking you through a tour of our data collection and data dissemination. And Alistair, after me, is going to be talking a little bit about the standards and some of the packaging of the tools that we have for the data preparation. So my hope for today is to give you, into this data exploration, a brief taste of what we've been collecting. And when I say collecting, we recently closed the 10,000 plus recordings for the Bridge2AI Voice and over 4,000 tasks, which we're going to be diving into more detail. I'm going to be talking about the data collection life cycle, give you some examples, tell you where you can find all our validated questionnaires, acoustic tasks. I'm going to be giving you a brief demo of the app if the demo gods are willing. And then I'm going to be taking you through a data deep dive of how we collect internally, passing the torch then to Alistair to talk about how do we get the data over to you and how we package them. So from a high overview point, what we have is we have developed these tablet applications that allow us to collect voice, discrete data such as validated questionnaires, and essentially our Bridge2AI voice participants visit our clinics in both the US and Canada amongst a different set of voice disorders. And I think there's 5 distinct disease categories. So there's voice disorders, mood and major depressive disorders, central nervous system neurodegenerative disorders such as Parkinson's and Alzheimer's. There are respiratory disorders, and there's the pediatric one with autism and speech delay. So we have both a tablet application and a browser application that we're going to be talking about on how we enroll participants and how we collect the data. Our data lives in Azure, Microsoft's Azure in the cloud. And we have leveraged Bridge2AI APIs that we have developed to disseminate the data to our REDCap databases. So REDCap is short for Research Electronic Data Capture, and it's become a standard in clinical trials. And at the same time, how do we store our audio files? So these are the .wav files, and how do we disseminate? This is an early version of the portal that we have. Alistair will be talking in more details about the plans and how this will be coming up to you. Now, I'll try to give a visual example of what kind of questionnaires our participants might see to fill out. This is a validated questionnaire called a PHQ-9 or Patient Health Questionnaire 9. And all the stuff that you see today, you can go to our GitHub and download them, either by scanning the QR or typing the link. And I'll be making sure to make the slides available later on so you can see it. So the typical validated questionnaire here, it's almost like a Likert scale. There are some sentences, and as you fill them out, the data are collected from the tablet, transmitted directly to our system. At the same time, we also have a voice sample. So if you could see my video, this is some of the headsets that we connect directly to the iPads. And the protocol, depending on the protocol, they are positioned at a fixed mouth to microphone distance. So if there are acoustic tasks that revolve breathing sounds or coughing sounds or speech, the protocol will be adjusted so that it captures the optimal quality of the audio. And together, as we'll go through the app, I'll show you some additional adjustments that we have for each acoustic profile. So I want to give you an example of an acoustic task, namely a prolonged vowel. And on the right-hand side, you'll see a QR code with a YouTube playlist that has all our acoustic tasks. So before I go ahead and play it, I'm going to try to share sound, and please let me know if you cannot hear it, and we'll try to figure it out.
This task is called prolonged vowels. The participant will be asked to count.
Can you hear the sound?
Then hold out the vowel for 8
Yes.
seconds. Yes. We're looking at perceptual voice features such as pitch, loudness, and duration. We're also looking at variations in voice quality. Chant the numbers 1 through 3, then hold out ah for 8 seconds.
1, 2, 3.
So what you saw was an example of how to do a prolonged vowel task with demonstrated by Iris and Carly. These are research assistants in our site at USF that they've also been collecting data with our participants. And this is to give you a sense of the type of tasks that these protocols include. Now, you can find all that available in our GitHub. And in fact, I'm going to try to walk you through before we dive in the app to just highlight a couple of things that you will find in our repository. In addition to the data, there is some information of how much, what are the tasks and the recordings for each protocol, what is the estimated time to complete them. And we factor that based on ranging in our feasibility studies, how long did it take our population to fill it out, and we're continuously refining them based on the time that we collect that the tasks are being completed. And as I said, there's 4 distinct categories, and there's the generic protocol question. So you can see the total estimated time to complete this task. So these include also the generic protocol that is combined. So we have tasks that are across all protocols common. And for each of these tasks, you can find whether it's a questionnaire or an acoustic task, and you can find its corresponding information. So for example, in the patient health questionnaire that I was looking on before, where is that? There it is. I can open a link and I could see directly the PDF information about the task. And similar to the patient health questionnaire, I could click on a video here and it would take me to the list. Now, the repository here, what it contains is all the recap information from enrollment, all the steps. And if you have a REDCap database system, you can actually go ahead and import all the data dictionary and metadata to basically scaffold your own. So this is a brief explanation of how you can find all the protocol details of what we're going to be going through. Now, to give you a sense of the app demo, and as I was talking, you might have seen some of the tasks that I was preparing for you. So I'll go and why don't I go and exit the app and launch it again. This is the app that we use in the clinic on my left-hand side. And essentially it has two main components. One is for enrolling participants where they can select their language, customize their experience based on their visual, auditory, or motor or cognitive impairments, and check who is participating in the survey, learn some of the information about the study, etc. And we have also some accessibility features such as you can adjust fonts and things like that, but also anything that is natively supported by Apple's accessibility ecosystem is baked in the app and is supported. Now, on the data collection element, and what you will see, as you see it on the bottom here, it's our develop app. So any of the names that you see are all fake names except for my name, which is a real person. So John Doe is not a real person, and Gary Horton also isn't a real person. They have all my email. So basically, all of these are from a site called Fake Name Generator, and we use it so that we could have some variance in how a data set would look for our developers. So in this particular example, John Doe is a control participant for all the disorders, meaning it is for us to be able to select them. And as clinicians, I'm allowed to fill out their clinically validated diagnosis that you would be able to see on the bottom right, the forms. But also I could go ahead and select a set of tasks. So there are specific bundles, as I was showing you before, that the research assistants can select. So these are each of these bundles that select the tasks that you see here and which protocols they are. For the economy of time and to preserve some valuable time to hear also Alistair, I will select, to give you a sense of the PHQ-9, I'll select the thing we did, the prolonged bowel, and perhaps I could do some neurological disorder one, so I'll do a test vinaigrette one and a word color soup. I won't complete all of them. I just want to give you a taste of how the app looks. So here I could go ahead and reorient some of these tasks. So I can mix them. Some of them can be questionnaires and then have some voice tasks to give people with vocal disorders. So for example, if I have vocal fold paralysis, doing all the tasks in a repetitive fashion might put strain in my voice. So we can sometimes mix and give people some breathing room. And one of the things that you will notice immediately as we have a set of tasks to complete, there's an audio check test, right? So what does this do? This allows me to record a set of samples, and I'll make the font a little bit bigger. As you see me speak, it is the iPad on my left that I'm looking at is picking up a microphone and has already some microphone gain adjusted. So you will see as I'm speaking, it is optimal in the green level, and I could adjust the sensitivity. And as I speak now, you will see that it's going closer to the yellow or the red area. And this is not where we would like to be. So our data acquisition team has worked together with our tool development team to optimize these in a sound booth and collect audio samples to make sure that the audio that is collected is at the optimal level. But because not everybody has the same, let's say, volume that produce, we can adjust it to tailor it to each person. So I'm gonna go and do some test recording. So here it says testing 1, 2, 3. And then I would say I'm happy to participate in the Bridge2AI study. And I can go and hear back these particular tasks. So by clicking on that, I can listen to the tasks and see that there's no connection issues, that the audio is picked up fine. And I just set up the speech profile for my speech tasks. Now there are cough-related tasks. I won't cough in the microphone because although the gain is going to be low here, through the Teams meeting, you'll hear it penetrating your ears for the ones that are wearing headphones, so I could cough. And then what you would see, the gain is maximized out to capture breathing sound. So we want to capture every minute kind of respiration and breathing. So having configured that, every task that will follow will adjust based on these profiles. So I had selected 4. We're going to do only a couple to briefly, in a cursory way, go through, and we won't get worried to fill them out completely. I just want to give you a sense of how it looks. So I'll try to adjust this a little bit more so that we can get more on the screen. And here there's, over the last 2 weeks, how often have you been bothered in any of the following problems? And what I typically try to do is randomly filling these out when I'm just testing. And one of the things that I want to point out that PHQ-9 has is this test for suicidal thoughts of behavior. So the first thing that will come is, if I go in a questionnaire and filled out that I have thoughts of being better off dead or hurting myself in any way, well, maybe the priority is not filling out that questionnaire. And if I end up actually putting that information, then the thing that I should be reaching out, and the research assistants that are there to help me, is to offer me help, right? So I'm just going to go and click not at all on this, and I'm going to continue because I'm feeling actually very well today. And this, that step, I just completed all, and the data went through the cloud and they're synced. Now I'm going to do a voice task. So similar to what I did before, I'm going to count to 3. 1, 2, 3, and I'm going to say, and you will see it recording, and I should be able to hit the button, and it's good to go. So that too is uploaded in the cloud, and we will be able to see it shortly. So as the data that we're filling out are being done, and one thing that I didn't show, I'll show to you in the next word color stroop, any kind of voice test that I was talking, like a prolonged vowel before, has the video tutorial baked in. So if we ever forget, we could click, and within the app, Iris or Carly will demonstrate how this task should be performed. So it's also a self-paced tool. Now, the Winograd questions are these kind of tricky questions that have, like, is it A or B? I can't cut that tree with that axe. It's too thick. What is too thick? I guess it is the tree. And I'll go and randomly answer the rest. And we'll see how I do today. And then there are other tests like word color stroop. So these are cognitive tests. So if I want a reminder of how this works, I could click on that and I'll see a tutorial that will walk me through on how I could do the word color stroop test. And basically this task is a little bit different. It displays a word and a color. And in this particular scenario, I would have to say the name of the color which the word is displayed. So that would be brown and not blue. And these words cycle. I'm not going to go and complete that, but I'm going to go ahead and kill the session midway so that you can see how that session also looks. So if there's not enough time or the participant cannot proceed with a long protocol, there's still a way that you can collect partial data. Now, in this specific example, on what you see on the right-hand side is our REDCap system. And as I was filling all the data, this has been collected. So I'm just going to hit refresh. And you see now I have a new session. This participant, I would say, is not looking very optimal, has too many sessions, too many recordings. But I'll give you an example of the last acoustic task, and that was the prolonged vowel. I'll remind you, I did not complete the word color stroop. And as I go to each task, you will see that I completed the audio check, and I could go and see, for example, let me go and how did I do on the Winograd? In other words, do we still got it? So I actually answered 3 of the 5 correctly. So, I mean, a 50-50 thing really ensued here, I guess. And we have metadata, what were the questions that were asked, and I could really go to each of these questions and see how well did I actually perform. So this is just to give you a sense of how the data can immediately flow through. Now, going back to my presentation, how is that data structured? So we show that there's a participant can enroll, and a participant can have also a given diagnosis, and they actually can have many diagnoses. In our case, with John Doe, but primarily he would consent a person to a study for at least one. And if there are control participants, they would be able to enlist that control. Now, a participant can have multiple sessions, meaning what we just did right now was a single instance of a longitudinal data capture. And we filled out some questionnaires and some acoustic tasks. And some of the acoustic tasks, namely the word colors true, has multiple recordings. So the idea is, as we have all that structure, how do we deliver them downstream to you? And I gave you the deep dive of what RedCap delivers. And a couple of the things that RedCap can deliver for us is a whole slew of very, very detailed CSVs that look in these kind of element. That one thing that you'll notice, it has a lot of empty things that both Alistair and I don't really like. So, I mean, CSV, you can beat it. It's very simple, but just to give you a sense, we capture over 1,400 fields of our data. So if you look at the demographics and confounders, it's a slew of details in a longitudinal sense. So there's a ton of empty fields, right? And as Alistair will show you, there is a better way, there is a standard way, and he'll go into that. And I think with that might be a perfect segue to pass the torch to Alistair. Alistair, you want to take over? Floor is yours.
Awesome, thank you. That was smooth. So let me just move everything away from this screen and share it, and then we can get started. Yeah. Okay, so let's talk about the organization of this data. So I'm actually going to speak a bit to some more general standards than what we're using here, because our goal really was to adopt sort of existing standards, try not to create our own thing. So I'm going to talk about basically three things very briefly, as we have a limited amount of time. I'm going to speak about FHIR and give a little bit of an introduction to FHIR. This is very broadly useful because FHIR is emerging as a very widely used standard in medical informatics and in exchange of data among medical providers. Then I'm going to speak to a slightly lesser known standard called BIDS, which is primarily used in brain imaging, but it's nice and it makes sense, so we're adopting it. And then I'll speak to some tools that we've made open source to analyze the Bridge2AI data, the Bridge2AI voice data that we're actually working with, and I'll demo them briefly just so people see what they look like. Okay, so let's talk about FHIR. So FHIR stands for Fast Healthcare Interoperability Resources. It's an acronym that's designed in a slightly poor way, in that you're very much encouraged to talk about FHIR resources in the same way you're encouraged to talk about ATM machines, and you repeat that last word, condition known as redundant acronym syndrome, or RAS syndrome, which I always enjoyed. So basically, FHIR is a way of exchanging data among two individual entities, typically healthcare providers, that is all encapsulating. And FHIR is based on a set of principles called REST, which were really the foundation of the modern internet. And so we'll speak a little bit about REST, and then we'll speak about FHIR, and hopefully you'll come to see, as I have, that it's really not too complicated. And it is extremely useful for sort of sharing data and making sure that your system can scale to any number of individuals who want to access any number of individual records. So initially, we had this approach called SOAP, which I won't talk about, but it still exists in some healthcare systems, and you might run into it in its different protocol. Now we have REST, which basically is not a very strict set of rules. It's a set of principles that you have to follow. And if you follow these principles, then you say your API or whatnot is REST or REST compatible, and that's meaningful in the information exchange sense. The other reason why we'll speak about FHIR and why it's sort of useful to know is that it's actually required in the US now by Congress. So they passed a law that said, hey, if you are a healthcare vendor, if you are operating and using healthcare data, then you have to make this information available. You have to make this information available to patients, among other individuals, and you have to do it in FHIR. So now all of a sudden there's a lot of table stakes for sending data in FHIR. So this is also encouraging its uptake. Okay, so what are these REST constraints around FHIR? So there's 5 of them. Honestly, the last 3 are complicated / somewhat implementation details. The first 2 are really the magic ones. The first 2 are client server separation and stateless server. And so this is really enabling us to share data without getting locked together. If you imagine a system where we retain a state where we aren't stateless, what does that mean? That means that when I'm talking to you and you're asking me for a medical record, I'm actually keeping, I'm sort of only speaking to you at the current time, and I'm waiting for you to finish before I move on to the next person who wants data. And you get sort of tied up if you build a system like this, because all of a sudden your server is waiting for clients to finish. So the REST constraint here is that you only ever interact with the client requesting data through a request. Otherwise, you're not remembering, otherwise you're not interacting with them. And then your server is not maintaining any state. So if somebody comes back to you and asks for more information, you are not allowed to remember that, oh, this person has sort of, this is John Doe and I've already sent them this information. So because I've already done that, I'll send them this instead. You're not allowed to do that. You have to, every time they send you a request, it has to be like the first time you've ever interacted with them. And so just to make it a little bit visual, basically, that implies that whenever the client is asking you for data, they have to send you all the information that you need in order to process it. You can't allow them to assume that you remember them in some way. You remember some information they've sent you in the past, and this ends up resulting in these like really verbose sort of requests that get sent. Which is why you'll see in a little bit that FHIR can be quite verbose. So if we look at an actual example of this, then basically we have some client who wants data. So this is a patient, for example, right, who wants the information that the electronic health record has about them, wants to know, what demographics are available for me in the EHR. Well, then they'll send a request. It will be a GET request because they want to get information. There's a bunch of miscellaneous metadata that is sort of a part of sending requests when you send requests over the internet. And you say, hey, I want this specific information. And then the server says, oh, okay, this person wants this specific information. It might check security, it might check authentication, et cetera, so on. And if it all goes well, then it sends back, the data. It sends back a response that matches what the request was. And in this case, this response is about a patient, might have their medical record number, might have their name, demographics, and so on. And then the server is done. And so this is sort of a REST interaction. This kind of communication pattern follows REST. And so FHIR is built to fit into this. So FHIR essentially is a whole bunch of information about both how to do this request process, but also about how to structure this response. And that's really where we're going to narrow in on, is how do you structure this data? So this is what it actually looks like, and this is a questionnaire response resource. So this is what FHIR is in the end. It's a whole bunch of rules around, hey, when you send that response, when you send that data back to someone, these are the things that you need to include. These are how you include them. These are what they look like. So one of the interesting, they call it an innovation in medical standards, though when you hear it, you'll sort of also be surprised, as I was, is that it's actually all openly available. So medical standards used to be very limited in their distribution. You used to have to spend hundreds of dollars to get access to them, and FHIR is completely open access, openly available. You can go to this website and you can read through it. So that really helped the proliferation and the understanding of it. The second thing is that their documentation is very detailed, and once you understand how to read it, is very useful. So this is a questionnaire response resource, which we'll talk about a lot because that's what a lot of our data is in. And this is basically saying, when you have a response to a questionnaire, so that's something like somebody is asking me my Glasgow Coma scale, which is, okay, hey, are my eyes able to move? Am I able to speak? Am I able to move my arms? It's sort of a 3-question questionnaire there. My response could be coded as a questionnaire response. And so what information would you send in that? So say you are a medical practitioner and you wanted to measure my Glasgow Coma scale. Okay, you ask me these 3 questions, you get this answer. What information should you store for that questionnaire response? FHIR tells you it, and FHIR's promise is that, oh, we will cover 80% of the information that you need to provide there. So let's look through it. So there's unique identifiers, but which are there, great. The subject of this. So who is the subject of this questionnaire response? Well, if you're asking me a questionnaire about me, I'm the subject, right? Is this related to an encounter, a hospitalization or an outpatient stay? Who authored this? What is the source of this? So maybe the questions are about me, but they were answered by a representative of mine, in which case the source is different. So you can see FHIR is really nice because they've thought of all these different edge cases that you might not think of, oh, I need to collect this data and that data and that data. They say, well, we cover 80% of the information that you would need to collect. And of course, you're your own local hospital and you have your own unique snowflake way of doing things, so you can extend it, and we expect you to do that, but we'll cover most of your bases. And it's very helpful from that perspective because this can sort of jog your memory of, oh, I need to collect this data. So you sort of have those elements, and then after that, you have the items of the responses. Question 1 is item 1. The response to question 1 is item 1. The response to question 2 is item 2, and so on and so forth. So that's kind of the description of, this is what FHIR is actually standardizing. It's saying, hey, when somebody responds to a questionnaire, these are the data elements that I expect to be there. These other columns, the flags column is telling you about sort of special information. It's usually not that important. The cardinality is telling you how many of these data elements do you expect. So for, say, a subject, well, there should only be one subject of the questionnaire, right? There should only be one source, the person who answered the question, only sort of one person, right? Whereas for question answers, there can be more than one. There can be as many as you want. So this is great. This gives us a framework for actually storing all the data for all these questionnaires that people have responded to in the course of this study. These are basically, even though FHIR covers patient resources, encounter resources, observations, lab measurements, currently for the project, we are only really using two of the FHIR resources. We're using questionnaire resources and we're using questionnaire response resources. Now, in the future, they're very hopeful that changes as we expand our data collection. But right now, relevant to the project, these are the 2 resources that are used. And so the questionnaire resource, unsurprisingly, is a structured representation of these questionnaires that we're asking, which I'll show an example of. And then the questionnaire response stores the responses. One thing that is maybe a subtlety and kind of confusing to me, and maybe confusing to you as well, is that when you create, say you instantiate one of these questionnaires, like I want to ask someone about their demographics, you actually don't make a new questionnaire resource, you make an instance of a questionnaire resource. So that terminology is important and it means something. It might not mean something right now to you if you're unfamiliar with FHIR, but that is a little bit unusual in that you're making instances of questionnaires rather than necessarily doing a more usual FHIR extension of them. So let's actually look at an example of one. They're all public. All of the questionnaires that we have are public. And so this is our sort of demographics questionnaire, where basically, what city. So when a participant comes in and we're asking them questions, we ask them about their demographics. What city do they live in? State or province, zip code, country, so on and so forth. And we store the data. So the questionnaire instance describes what questions we asked, and then we store their responses in a questionnaire response resource. And then this is what a response actually looks like. So in the end, it's represented on the computer as a JSON, which is JavaScript object notation, and it's pretty easy to read. This is a serialization of the format. So FHIR is not necessarily JSON. You could serialize it in other ways, but it practically almost always is JSON. So they're almost interchangeable. When people talk about FHIR, they usually think of like these JSON text documents. And this is just a text document, right? You're starting with a bracket and then you're saying, hey, the resource type is a questionnaire response. The ID is this. The questionnaire link is here. The status is completed, so this was finished, and here are all their responses. And so FHIR is putting the rules here to say, hey, the first field, the identifier, has to be named identifier. And so here in our response, well, that was a bad example because we're using ID, which is actually lower here, but you can see item has to be named item. And so here we have item named item. It can have more than one thing. So there's a bracket with more than one thing and so on. And there's a whole bunch of tooling which actually verifies that the documents you have match the appropriate structure. So that's FHIR. I think it's very useful to understand FHIR because a lot of data, a lot of information exchange will start to be shared in FHIR, and it ends up being a very, very simple building block that grows in complexity as you start to deal with a lot of data and a lot of different FHIR rules, and some of the nesting can get complicated. But at its core, it's a really, really sort of simple and powerful concept of all healthcare information can be exchanged as resources. And we just define these self-encapsulated resources, store the data, and we're very happy. So the second thing that we need is a way of actually organizing our data once we've stored it. So as Alex mentioned earlier, we have this hierarchy of data, right? So we have an individual participant and they'll enroll in the study. And so we'll have a questionnaire response for their enrollment, for example, and then we'll have multiple sessions for their data collection. They might come in multiple times if they're unable to complete their first session. They might come in multiple times because it's a longitudinal study. So either way, they may have one or more sessions. And then for each session, we'll have more than one sort of questionnaire that we ask them. We might ask them about their voice that day, do they have a cold, anything that might impact their recordings. We will ask them some sort of standardized questionnaires assessing their mental health status, assessing their sort of mood, and other sort of aspects of their health. And then we'll have multiple acoustic tasks, and each acoustic task may have more than one recording. So we have this very highly hierarchical nested structure for our data collection. We have a lot of responses, over sort of 10,000 responses, and we have a lot of recordings. And so it's very easy to start to lose track of so many recordings and so many responses. And so there's a sort of desire to have a good standard structure here. Now, the nice thing is that this hierarchy is actually not unique to our study. It's very common. Tons of studies basically boil down to this structure where you have a participant, you have multiple participants. Each participant has multiple sessions, and each session has multiple, tasks or IDs or whatnot. And so this is where BIDS actually comes in that BIDS is the brain imaging data structure, unsurprisingly, originally growing out of brain imaging, is just a folder structure for saying, hey, when you have data like this, let's use these folder names, let's organize it like this, let's follow these conventions. And then when you share this data with others, we'll immediately recognize the folder structure, and I won't have to look around to say, oh, hey, where are these images? So what happened in the past with brain imaging was people would share data, which is great, but they would always share it in different folder structures. Some people would just give you a folder with 10,000 files. Some people would organize it by subject. And so then you'd need to split out the sessions yourself. Some people would organize it by session, and so you'd need to figure out which subjects are the same. And there was always like an additional set of very boring, uninteresting work where you just reorganize their data into a format that you understood. So adopting a structure like this just saves everybody a lot of work because we see this sort of data organization all the time. And so that's what we've done, is we've adopted this sort of structure where we basically have a subject. So here's the structure: a subject and some unique identifier for that subject. We have a session and some unique identifier for the session, and that's nested within the subject. And then we have subfolders for the different modalities of data. So all of these questionnaires are treated as behavioral data. So they go into this BEH or behavioral subfolder. And so all our questionnaires kind of go there. It's not in the existing standard, but this is an extension of ours that we're adding an audio folder to store all the audio files. Typically with brain imaging, you would have sort of like a, MRI folder for all the MRIs. And then we have some schemas and some general, hey, here's the different data that we've collected, index files, which exist as well. So, okay, so that was FHIR, and then that was our organization of the data into BIDS. And so now it's, okay, how do I use this data? Well, as I mentioned at the beginning, we have sort of an open source repository called Bridge2AI Prep, which has a whole bunch of tooling for how to use this. Within the main thing I would recommend is within this documents folder, there's a few different tutorials, and this tutorial is quite useful, where basically, assuming that you have access to the Bridge2AI data, which, it's this tooling is only useful if you actually have access to it, then you can sort of run through this tutorial and use our tooling to better analyze the data. So I actually already ran the tutorial, and so I'll run through it here, where basically this tutorial sort of describes the structure a little bit, and I'll see if I can get rid of that for more space, and overviews the sort of the different structure. And the main utility that we provide is this load and pivot questionnaire, which essentially loads and pivots a questionnaire. So it actually, for a specific questionnaire like demographics, you would pass in the name of the schema, and it would load it into a single data frame, which you can then analyze. This is a lot easier than working with that REDCap CSV that Alex mentioned earlier, because you don't have to deal with the problem of knowing, oh, is this blank because they didn't collect the data, or is this blank because I'm looking at the wrong row and column of a REDCap CSV. So if I scroll down to the demographics data frame, right? So this is basically pulling in our demographics, and we can see here, right, we have a few different individuals and their state and province and their country and their gender and so on and so forth. And this you just load in very easily, and then you have a single data frame with all the demographics. So this tutorial goes into quite a lot of detail about the different identifiers and whatnot in the data. So that's one very useful thing. The second very useful thing that we have is if you launch, let's go back to here, right. So, okay, so then a natural question is, well, how did I know it was named the demographic schema? Well, there's this protocol page that we've created, which goes over that protocol that Alex was talking about, which says, hey, this is what we ran through with all the participants. So we started with, eligibility and consent, and then we asked them about demographics, and then we went through some acoustic tasks, and then there were some, confounders for their voice and so on and so forth. And so if we look here at the demographics questionnaire, we can click through it, and then that string that I used to grab it was right here, the Q generic demographic schema. And so the tooling makes it very easy to look through here, look through this web page, see that, oh, this is the information that I'm interested in. I'll grab this demographic schema and move on. Yes. So the last thing I'll talk about before making time for questions is the dashboard. So this dashboard is meant to make it kind of easy to explore the data. You run it by just calling dashboard and then pointing to the folder which has the data. So I've already run it here. This is a Streamlit dashboard. Streamlit is a really wonderful library, which basically lets you very quickly build dashboards like this by writing individual Python scripts, which then execute on the fly and give you data like this. So we have, these are generated from the data set, 178 subjects, 204 sessions. I forget which version of the data set we're on here. Alex would know better, but this is a lower bound of how many individuals there are. So there's sort of a demographics page, which kind of highlights some of the different demographics of the data set. There's an audio page, which is very useful for going through all the different types of audio, which are here, sort of free speech, Cinderella story, all these different things for all these different subjects, which all have random identifiers. And then there's actually a search page, which is also very useful because this is doing a semantic search over the data. And so if you're not sure where to look for something, this gives you an idea of where to look. So for example, here I search for age, and luckily the variable that I'm interested in is also named age, and that's the sort of questionnaire where I would grab it. But if I was interested in like sex, it kind of makes me laugh that the closest to sex is marijuana, and I think it's a different definition of sex there. But if I do something like male, then I get, the column is actually gender identity and specify gender identity. And maybe if I do ethnicity, then I find all these different race columns. So I don't need to match the string exactly. I don't need to exactly find the name of the variable. I can search something that's roughly close, and this is very useful for finding, okay, all these questions were asked in the demographic schema. Okay, and with that, that's all the tooling. I will definitely share the slides afterwards so that you can take advantage of all these links and hopefully play with the data on your own time. And both Alex and I are open for any questions that anyone has had. I see one. No, I don't think we've done a good any publication on it or any sort of public documentation of bids. This is why I called it bids like, because we're testing it, adhering to the structure, and then I am absolutely going to punt this to Satra to follow the appropriate steps to extend it to bids properly, since he's far more intimately familiar with bids than I am. But I'm sure that's kind of what we would go for. So happy to join on that.
Perhaps if I may, while people are thinking of any questions, could you talk, we showed how the data is collected and we show how the data looks. The follow-up question is, how do I get access to the data? What is our long-term vision? I know we're planning a data dissemination platform. Perhaps you could share a couple of high-level details of how the data would be able to be consumed, to how it is delivered, the tarballs that we have, to give some clues of what to expect.
Sure. Yeah, I never like to do a recorded talk about something that is not yet available. But right now the plan is to publish a version of the data set on a platform called health data nexus, which I will put into the chat, which is essentially a data publishing platform, which also allows for sort of secure sharing of data, secure in the sense that you can share data within a cloud environment, which restricts data egress, so that you know that people are able to do research and not sort of accidentally leave the data on a laptop somewhere and potentially risk patient privacy through that accident. So the platform has a pretty streamlined and transparent mechanism for providing data access. You apply your account, you log in through using your university credentials through single sign-on. So whatever your existing university credentials are, you just use them. And then after you've done that, you submit proof of completing a human research with human participants course. So that's CT or TCPS2 if you're in Canada, like myself. And then once you've done that, you sign the data use agreement for the data set. That gives you access, and you get shifted over to a Google Cloud Platform research environment where you spin up a Jupyter Lab environment, and then you just do your analysis with the data already there. So we're planning on building that. Sorry, we're not planning on building the platform. The platform exists. We're planning on publishing our data set on that platform over the next 2 months, I would say, something like that. There is a process for publishing a data set on the platform. There's sort of ethics reviews and lots of checks and balances, so to speak. So little bit of time before that's available. But then once it's available, anyone with a university account and a legitimate research interest can apply and be provisioned access.
There's also a follow-up question from Harry. I think we could tackle half and half. One is about the choices on standards, and the other one is the choices on infrastructure. Do you want to take the standards decision-making? Like,
Sure.
what was the approach?
So the standards, it's a very interesting question, because there are a lot of little choices made. I would say it's the main choices that we made were where to back away from too rigorous of standardization. So initially we were thinking about standardizing a lot more of the actions done step to step, and in FHIR at least, it becomes extremely complicated to associate a sort of a questionnaire with a protocol, so to speak. So there are resources in FHIR to define an activity, which is what our data collection is. And you say, okay, well, step one in the activity is ask them this, and step two is ask them this. And we were initially using that, and it's just really complicated, and honestly not a perfect fit to our study. So we actually stopped using that, and we only use the questionnaire resources and the questionnaire response resources, which give us the data validation, which give us good structure, which give us interoperability and kind of consistency with the next reason why we have sort of FHIR, which is the future data collection from EHRs. We'll pull all that data in FHIR because that's what's mandated by Congress, and that's what all the EHRs will easily export. So there's a little bit of that was kind of one interesting decision that we made. And then a core reason why a lot of this data is organized into FHIR is a bit future-proofing it to the rest of the data that we will collect in the near future. And then I'll hand off to Alex for infrastructure.
Yeah, so there's two main components of infrastructure. One is what were the hardware decisions? In other words, why we chose that microphone, why we chose an iPad, and the more soft-related ones, why we went with cloud approach, why we went with the specific cloud provider, why did we choose RedCap? So from a hardware infrastructure, I think the two main goals was we wanted to have a low-cost microphone. I think that's in the ballpark of under $20 that we had research shown that could perform really studio quality voice capturing, right? So this is work that is not just done by me and Alistair. There's Dr. Spar, Juan, our whole data acquisition team that are acoustic engineers. In addition to the, let's say, fire-related or the informatics standards, they were instrumental in developing and choosing the right hardware. In terms of the iPad, I mean, looking at the US in terms of the tablet market, it's a very well-guarded Apple ecosystem. And I think the main thing around it was, what was a device that could be very easily deployed in the clinics? And two, what was a device that would prioritize accessibility? And from the multitude of different tablet options, we chose at the time the Apple ecosystem as the more well-rounded option, and its framework allowed for very fine grain, like bare to the metal, like microphone gain adjustments and things like that. As we go to the remote data collection, obviously we need to cater for the rest of the world. So both iOS and Android platforms are to go out so that we can reach out to more people. But that's as far as the hardware infrastructure. In terms of software, RedCap is the de facto #1 clinical trial tool, and we wanted to not reinvent the wheel and capitalize on the experience that our clinicians and our research assistants had, the feeling familiar with that ecosystem, to be able to not just capture the data and go to a relational database, but to be able to have this what you see is what you get approach. And if it's something would change in the enrollment form, to be able to freely do it, even if the iPad, let's say, would not be with fully charged with battery. We want to have the full flexibility around that. Now, in terms of a cloud approach, all the NIH works with a program called NIH Strides, and all the cloud vendors, the usual ones, Google, AWS, and Microsoft are available. And I think we chose Microsoft towards the amount of support and guidance that it had, especially on the cybersecurity front, right? So they've done a lot of work on security and health data privacy. Maybe today is not the reason to mention that name in terms of reliability, but people might be familiar with that. But I mean, our system didn't fall down. And it's important to point out that what you want to have is a very reliable system, and you also want to have people that are looking on the AI ethics as well. So there is a very well-established team there that is looking at both taking care of privacy and how AI is being used. And there's a lot of interesting elements that we found to proceed.
Okay, I think we are over. So thank you everyone for attending, and have a good weekend for everyone on the East Coast. For everyone on the West Coast, you only have a few more hours to go.
Thank you.